So now our next speaker is Professor Devendranath Singh, Professor Department of Civil Engineering, IIT Bombay. So the title of the talk is Mission Industrial Byproducts, Valorization of the Industrial Byproducts. So far we are discussing about the management of the waste, rehabilitation, reclamation. So now we'll go to the point is of valorization. If we can add some value to it, obviously we'll have a good buyer to take our product. Now, before I ask Professor Singh to start his presentation, I want to introduce Professor Singh here to our audience. Professor Singh is a faculty member of Civil Engineering IIT Bombay since 1994. Before joining IIT Bombay, he has served as Central Road Research Institute, New Delhi, and IIT Kharagpur for a short duration. He obtained his bachelor's, master's, and doctoral degree from IIT Kanpur in 1986, 1989, and 1993, respectively. So he has published more than 320 technical articles, out of which 232 are in the referred journals. He has already supervised 38 doctoral students with 8 ongoing and 35 master theses. He has filed 31 patents, out of which, including 1 US patent, 9 have been granted. So he is also the founder and the chief editor-in-chief of Environmental Geotechnics Institute of Civil Engineers, London, UK. He has been also editorial board member of several journals of repute. Due to his work, he has been awarded with many awards. I'll add few of it. He is the recipient of Excellent Contribution Award 2008 from ISMAG, we call it as, for significant contribution research, academic activities, and professional service in different regions of the globe. He is also the recipient of John R. Booker Excellence Award 2011, Richard Feynman Award 2014, and Canadian Geotechnical Journal Friedland Award 2019. And he is also uniquely fellow of 3 prestigious society. He is fellow of Indian National Academy of Engineers, fellow American Society of Civil Engineers, and fellow Institute of Civil Engineers, London, UK. So now I'll request Professor Singh to start his presentation.
Thank you very much, Sharath. Can you hear me and can you see my screen?
Yes, perfect.
Just to full screen. Yeah. Slides.
Yeah, so
now it's perfectly all right.
Is this visible? And you can hear me, please?
Yes, yes.
Okay. So thank you very much, organizers, Sharath, Krishna, and Dr. Lohit. It's a good opportunity for me to talk to all of you regarding the mission in which I am deeply involved right now. Having done a lot of research in the laboratory and some research and execution technology demonstration in the field, I have realized that administrators are not aware of what we do in our laboratory and how to delegate whatever we do in the laboratory to become a bigger national policy or an issue. Now, I'm very much thankful to the Government of India for this SPARC program, which has been very successful, and it has been quite instrumental in knowledge sharing, because all of us get a chance to hear the international experts. The topic of the short-term course is on geo-environmental and geotechnical issues of coal mine overburden and mine tailings. I took liberty of talking about a bigger picture, and I'm thankful to Sharath, Krishna, and Dr. Lohit for allowing me to talk about something of which A subset is coal mine overburdens and mine tailings. I have named this as a mission IBP, that is Mission Industrial Byproducts and Valorization of Industrial Byproducts. I'm sure most of you must have realized that everybody talks about municipal solid waste. But truly speaking, the backbone of the society or the country, particularly the developing countries, are the industries. And these are the places, industries, where most of the unwanted products, like industrial byproducts, are produced, accumulated, and they meet any sort of a failure due to unwanted activities. This could be human or this could be natural processes. So this was the seed in the mind, which I thought of taking it up to the mission mode project. Some of you must be aware of the fly ash mission, which was initiated about 25 years back in India, and this was a good success. The second avatar, reincarnation of that project or the mission mode work, is mission IBPs. This project, which is a mission mode project, is being done for Indian National Academy of Engineering. And the mandate given is that we should come out with a technology roadmap with actionable recommendations. And I have named this as Industrial Byproducts for Sustainable Infrastructure Development. I'm linking sustainable infrastructure development with valorization of industrial byproducts. So what I'm going to show you today is that what is my philosophy behind this launching this mission mode project, what has been done so far, and very importantly, where I require assistance from all of you, experts, non-experts, beginners, or industries, corporate offices, even the governance. So this is what actually I'm trying to do. So if you visit my web page, you will realize that I have created a separate icon for mission IBPs. Now, if you click over here, this is what the description of IBPs is, which I'll be discussing a bit. And at the end, you will find that those of you who are interested and can think of helping me by participating in this activity can join this mission by giving all the credentials using this link. Now, coming back to the second thing which I have done in the recent past is my laboratory, which was known as Environmental Geotechnical Laboratory, has been converted into laboratory for geoenvironmental research and innovation. This is where you can visit it and you can contribute to the comments. Now, moving on to the philosophy. The philosophy is very simple. Earth crust is being exploited in the form of mining activities. We dig out ores, we take them to the processing units, mineral is extracted, everybody is happy, industries are making money, nobody bothers about what is going to happen further on. This is where the byproducts are generated, and these byproducts are transported at different locations. We call them as dumping yards, stacks. These could be lagoons where we are storing them. This could be the disposal ponds, and so on. And people have started realizing that handling, disposal, and storage of all these types of industrial byproducts is becoming a major task, major problem. So there's a big question mark where a lot of environmental geotechnology related issues have to be discussed, and I'm sure Previous speakers have already talked about this. Partial uses by the construction industry has already been demonstrated. It has been very successful. Unfortunately, geo-environmental applications have not been done much of this waste, and sustainable development part was also missing. The major thing which is in my mind is how to utilize these industrial byproducts, bulk of them. Like India produces hundreds of millions of tons of each of these waste, which I'm going to talk about, per day. The question is, unless we clean up this, industries cannot go ahead with their task. Industry ultimately wants to generate the product, not the byproduct. And even if the byproducts are being generated, the big picture or a better picture would be to utilize these byproducts so that we can create more space for tomorrow's dumping. So the theme is how to utilize all these industrial byproducts in bulk, millions of tons at a time. The potential IBPs which I have selected are the bauxite residues. It so happened that most of my funding agencies or the sponsors happen to be the guys who are dealing with red mud in the country. The slags, copper and steel both. Ash from combustion, different type of ashes which are coming out of the combustion. Biomine waste. Krishna Reddy has done a lot of work in this area. And the issue is that when we talk about municipal solid waste, there are big mountains of landfills, which have been created in the middle of the cities. People are clueless what to do with this. And this is where my idea is that the biomining should be done to clean up the land, and we can utilize it for better purpose. But the questions are several. Once you start biomining, where and how you are going to dispose the materials which are coming out of the biomining process. So that's a big challenge. And of course, the mine tailings and overburden from mining is also a part of this mission. And that is where I said that it so happens that the theme of this course, short-term course, happens to be a subset of the mission IBPs. These are the priority areas, apart from which I am also dealing with construction and demolition waste, dredge sediments, because I'm located in a city like Bombay, where several ports are there, private and government operated. The biggest challenge is what to do with the dredge sediments, where to store them, how to reuse them, how to do engineering out of them, and so on. And of course, coal washery residues. I was lucky enough to be a part of a big project in the central India, where utilized the coal washery residues for creating the railway embankment and the sidings. We are also talking about agricultural waste, which is very contemporary and in the context of India being a agrarian society. So bio waste, agricultural waste is also a part of the mission IBPs. And out of so many modules, which I call them, the first 5 are the top priority because the volumes are really tremendous. And industry is very happy to collaborate with the academia and sort out this issue. The motivation comes from the fact that industrial establishments in India and all over the world contribute to the growth of economy through good output. This good output is something like product, main product. Like look at the thermal power plant. What they do is they produce electricity, good output. But at the same time, they have been struggling to deal with the bad output. And what is bad output? Fly ash. All right. So similarly, steel manufacturing industries, they are producing steel, very fine. But at the same time, the bad output is slag. So these type of coupled phenomena are happening everywhere. So this is what the genesis or the motivation for taking up this project was. I also wish that IBPs should become a part of the mission Waste to Wealth and Welfare. And this I call as WWW, through recovery, recycling, and reuse. In fact, I have suggested to Government of India to create a different ministry, which would be known as WWW, that is Waste to Wealth and Welfare. Welfare is becoming very important, and in the subsequent discussion today, I'll be showing you how waste to wealth philosophy can be also linked with welfare of the society and individuals. And that is what the mission IBPs is. So we want to achieve this through recovery, recycling, and reuse into a very well-defined policy. However, I'm sure those of you who are working in this area, dealing with the industries, must have realized that the policies are really missing. And right now, I have taken up this agenda of creation of policies at the national level. So the bottleneck in addressing these issues are quite clear. People understand lack of implementable and or scalable technological solutions. Many times we researchers are very happy with whatever we do in the laboratory. Unfortunately, this cannot be scaled up. This cannot be implementable. And this is where we get defeated by the questions which are being asked by the administrators, the policymakers, that can you demonstrate this happening in the real life? And that is where we have to be very, very careful. The second issue is regulatory and policy issues, which is a major thing to talk about. These are the impediments in adopting recent innovative technologies. Every time you contact these authorities, they'll be asking you a question: was this done earlier? Where are the regulations? Where are the courts? Where are the policies? Well, we don't have these answers. Now, this is the job of the administrators to take care of, facilitate R&D related implementation of projects. So this is somehow not actually at the desirable scale in many countries, I would say. So my idea is that this exercise would provide actionable inputs and recommendations for policy formulation and their implementation. And this is where I need your help and support. My request to all of you would be, based on my questionnaire, which I have shown to you on my website, you can write to me. I can share the link with you. Please participate in this activity because this activity cannot be done alone unless all of you from the entire world collaborate and work together. You'll be happy to know so far I have received 62 responses, and most of the colleagues are from different countries who are contributing to this project. The main idea is, what are the success stories they have already established? What type of laboratory studies they have done? What type of field scale implementations have been done? What are the bottlenecks where they fail in implementing it at a bigger scale? All right. So I want to learn from the experience of the West and the Far East, what's happening there and why something cannot be done in the country like India, where we have all sorts of resources, we have the best possible talent which is available in the world. So this is a bigger thing which I am trying to talk about. The whole idea is I want to create actionable inputs and recommendations so that the policies can be created to utilize different types of industrial byproducts. Incidentally, what you have been talking about is the mining residues or the overburdens and so on. So the objectives are to estimate the nature and scale of IBPs. Number one thing, people are shy. They don't share the information with everybody. All right. Industries have never disclosed what is the amount of industrial byproduct which is tagged or disposed within their premises. So unless they open up, this task becomes very difficult. All right. So when I say we have to estimate, we have to create a sort of a, we have to do a sort of a mapping all over the world and within India. What are the places where industrial byproducts are lying in the form of stacks or disposal ponds and so on? And what is their impact or the potential or the threat to the geo-environment? Now, when I say threat to the geo-environment, we talk about air, soils, rock, groundwater, and neighborhood. I'm sure many of you can recognize this, a red mud pond which breached and caused chaos. And in my own country in India, this happened few months back, and there was a breach of the dike from the ash pond. So these pictures, challenge us. What should be our role? in nation building. Disposal of industrial byproducts is becoming a big issue and challenge. Everybody is realizing that their disposal facilities have lived their life. They are aged and they have already exhausted their capacities of taking the fresh industrial byproduct, and they are prone to failures. Audits have never been done regarding the stability of these systems, about their age, about how the weathering process might have changed the properties of the geomaterials which were used for creating them, maybe 60 years back, 70 years back. There is no availability of land. I mean, you talk to industries, the biggest question is they can't expand the disposal facilities. Like in cities, you can't expand the MSW disposal facilities, landfills. It's becoming a very hapless situation, and operations to be continued or permanent closure is being thought of. Like industries are thinking about this, whether we should continue our operation or we should close our operations completely. Now, closing operations is not going to be a solution for developing nations particularly. So this is where the valorization concepts fits in extremely well, and clubbing it with circular economy. So I was talking about WWW mission, So where is the welfare? The welfare comes from the circular economy attached to the valorization of industrial byproducts, which is mostly an industrial process, all right, adopted by geotechnical engineers, civil engineers, technologists, followed by creating a circular economy out of it. And once this is done, this will be a very win-win situation for everybody. The second thing is we would like to assess the status of the existing scientifically proven innovative emerging technologies for valorization of industrial byproducts. This is where I said I want to audit who has been successful in valorizing the industrial byproducts, both at field level or in the laboratory level. So these are success stories. Out of these success stories, apart from writing papers, how many codes have been developed? Because this is what the administrators ask you. The agencies who are going to implement it ask you, is there any codal provision for utilizing this material? And we got a very sorry figure over there, because research has not really percolated into creation of codes, the code of practices, all right, policies. So valorization of IBPs for different applications, sustainable ecological infrastructure development. This is the main theme, being a civil engineer and a geotechnical engineer. We want to do this. Monitoring the impact of the industrial byproducts on ecosystem, both in their native and recreated state. Suppose if you utilize this industrial byproduct, create something somewhere, how it is going to impact the geo-environment, both in the form of the stacks which are present over there, and how these recreated systems would contribute to the contamination. Creating policy guidelines to identify IBs as a man-made resource. I'm sure my idea is that all these industrial byproducts can be converted into man-made resource, either through in situ or ex situ neutralization or man-made soils. So some of my research scholars are working on this concept of converting IBPs into man-made soils, and there has been some success. I will share some results with you. The biggest issue is transportation of the industrial byproducts. If I want to transport industrial byproducts, there are no policies. People say it's a hazardous toxic waste, you can't even touch it, you can't even transport it, you can't even courier it for testing the samples. I mean, there are these type of regulations, unfortunately. So creating policies for transportation of IBPs in bulk from place of disposal stack to the place of utilization. If this happens, 90% of the task is done. Because I know that technology is there and we can use the material without any problem. And of course, I wish to create a task force in the mission mode for industrial byproducts. And then we have this, creating a task force in the mission mode for IBPs and formulation of relevant codes, manuals, standards, and the guidelines. Another challenge would be transition from policy to practice, which is very challenging, and exploring the possibility related to the circular economy revolving around industrial byproducts, particularly after the COVID-19 situation. Background work, several meetings have been done. I'm sure Sharath was also a part of this. Some of the audience were also part of this activities. All these are available on the website. When you visit my Mission IBP's link on my webpage, you can find everything over there. We have created status reports and already submitted to the Planning Commission, which is known as Niti Aayog of Government of India. And Government of India is fully aware of our initiatives related to this. And in this context, I have also collaborated with CII, Confederation of Indian Industries, and we are doing things in the form of an MOU with them. And a Google online survey has been prepared, which you are most welcome to fill up and express your interest in participating in this activity. Several PhDs and projects and industrial collaborations are already being done in country, in India. Particularly, I am part of them. Some of them, I'm sure Sharath has done a lot of work in this area. And my other colleagues in different IITs and NITs are also involved in this type of a mission mode project, but it is to be integrated. Right now, it's all scattered and bits and pieces. So the key considerations are, now I'm going to talk about the circular economy, how the welfare part can be linked with this. Use the concepts pertaining to circular economy in order to create an online exchange. I mean, this is what I call as marketplace. I mean, if I am producing a lot of mining overburden, I mean, I can always exchange it with something else. All right, I can exchange it with some other resources, because as long as I don't need to fill up the mines, this is a, this is basically a sort of a situation which I would not like to create on the site. So exchange for realizing the source values embedded in the IBPs. If a marketplace gets created through circular economy, that would be something really wonderful. And technologies are enablers to bridge the gap between the creator and the user IBPs. So this is going to be a sort of a matchmaking. Who is producing, who is utilizing, and then we should bring them together. We want to generate a database for industry as an input, promote transparency in the whole process. We want to create livelihood generation of environmental entrepreneurship multiplier effects, I call them as, and convert waste to wealth and mitigate effects of the climate change. This is also getting linked with the CSR, that is corporate social responsibility. Now this is known as scientific social responsibility, of which I was a part. I was a member of that committee of the Government of India. So there's something known as scientific social responsibility, which is now looking at these type of activities. And I'm sure the people who are interested in becoming an entrepreneur, I call them a environmental entrepreneurs, right? Because they are dealing with these type of thoughts and ideas. They can become a part of this. And collaboration between academia and industry for contributing towards more sustainable development initiatives. What is the way forward? The way forward is the data from the individuals, researchers, industry is very, very crucial. Please share this data with us in the form of the research which you have conducted so far, technology demonstration which you have done so far. And this is what is going to help in creating future strategies. And this data analysis is going to provide a direction regarding the possible usages and identification of matchmaking of IBPs. So what should be added to one IBP to create certain thing, value-added material. This is what I call this as the matchmaking of IBPs. Sometimes I used to also call this as the horoscope reading. I mean, some of you who understand there's a big science behind the matching the horoscopes of the bride and groom before they get married. So it's something of that sort which, the thoughts process are on. Share the findings with the industry and obtain the feedback and guidance regarding issue of practical significance. And then, of course, the last one is documentation of the findings and suggest and recommend business opportunities and policy initiatives to guide further course of action. I mean, this is what I'm envisaging. You are most welcome to input your ideas and create this. I'd like to share in a few minutes my success story so far in terms of creating R&D. And I'm very much thankful to the Ministry, MHRD, Ministry of Human Resource and Development, Government of India, and DST and Ministry of Environment forest and climate change. And my collaborators from Hindalco, Tata Steel, and so on, we showed the application of industrial byproducts and sustainable development. Few success stories which I am going to share with you. We have used fly ash, bauxite residues, furnace slags, mine tailings, construction debris for stabilization of marine deposits. This was a project which was executed very close to Bombay City in terms of creation of a new port. And there we stabilized different, where we stabilized the marine clay by using different industrial byproducts. These are the man-made soil example where the red mud which is lying in the pond can be utilized as a man-made soil. I am working on this right now. This technology demonstration has already been done at Hindalco site and at Utkal, where we have created roads and the pavements for the for their traffic movement. And recent project which we have taken up is the mine backfilling. We have got sanction from the government of India, and they have allowed us to go ahead with our mine backfilling plans, where I'm using bauxite residues for, from where they came, that is the mines. These are the success stories so far. We have good publications to show the technology demonstration, and it's quite heartening that my students are doing so good in this part of the research. And we have patents also related to industrial byproducts for stabilization of the marine deposits with industrial byproducts. And we have created, this patent for road upgrades. And another device which has been created for simulating the neutralization of the bauxite residues by gas purging. This is under, under patenting. The patent has been filed and it's yet to be granted. I would like to draw your attention towards the recent advertisement which has come from the International Society of Environmental Geotechnology. This is where I'm sure you must have noticed that there is a center for geotechnical, geoenvironmental research and innovation, which I call this as SEGRIN, has been announced. So you can become a part of this also by clicking on this link and by sharing your ideas that how would you like to become a partner for SEGRIN. This is going to be a virtual center for geoenvironmental research and innovation. And my idea is that it's going to be a sort of a polyclinic for the researchers. In medical profession, this term is quite well known, but unfortunately in our subject, our research field, we don't have any polyclinics where you have experts, where there are patients, there are situations which require immediate attention. So my idea is to create this virtual center where people can collaborate, they can exchange their thoughts using the virtually equipments, knowledge sharing, and so on. I mean, sky is the limit for this. So thank you very much for your kind attention and a very patient hearing. Let me reiterate, I need your wholehearted support for the success of this mission. And I'll be very happy to take your questions, suggestions, or any sort of discussion which you wish to do. Thank you very much.
Thank you, Mr. DNS. So now I'll request our participants to write their queries in the chat box. Okay, so we have got the first question or query rather, I'd say, from Diptita Ghosh. Can you please elaborate on the valorization of agriculture? It will be byproducts really, agricultural byproducts.
That's right. So see, agriculture industry produces a lot of waste. I'm sure you must be aware of. And this is becoming a big challenge. I'm sure those of you who are from India and who are following the national network news during 4 months of the year, when winter starts, the national capital region finds it very difficult to breathe even. And I hope you can realize that why this point has been taken into account. in the mission IDPs. Agriculture is an industry, and the byproduct, I think you can realize in different forms, requires a very immediate attention. Is this fine?
Yes. So, what are the technical challenges faced while using the IBP in road construction? From Rajeshri Bhar.
Well, see, truly speaking, there are no technical challenges. The challenges are in the mindset of the people. All right. So still, there are agencies who keep challenging that if you use this material, something is going to happen, despite telling them that, well, I am going to prove that nothing is going to happen. Be assured. And I have shown them, in fact, that nothing happens. All right. So truly speaking, there is nothing untoward which is going to cause the environmental degradation or pollution. And we have already demonstrated this at 3 sites. So technical challenges are, of course, I mean, you have to be very patient enough to show that your technology in the laboratory gets delegated in the field. That's it. I mean, I don't think there's any technical challenge associated with this.
Yes. So next is from Sanandam. So, sir, what is the scope of ecological restoration for post-mining quarry area, especially using industrial byproducts? Ecological restoration for post-mining or quarry using industrial byproducts.
Well, I would wish to do this study, myself. I have done very recently a project at Bhanegaon mines where the open cast mines are being done. And those of you who are aware of, I have spoken at some forums where I have stabilized very deep, non-cohesive granular material slopes under the perennial river activities. So this was the project which was just completed some time back. There is again a question of who is going to accept this. All right. So, I mean, like our generation has tried our best to flag these issues. And I'm sure that the generations to follow has to take it and implement it. This is the status of the things. Well, I can't answer your question because I wish that I would have given a chance to do this activity. I'm very eager to do it. Yes, please.
Okay. So next is your Arvind. So best way to comprehensive utilization of mine tailings. What is the best way of comprehensive utilization of mine tailings?
I think, Sarath, you are an expert in the subject. You can give a better answer than me.
Yeah. So I mean, you have just showing that how we are backfilling the also some of the industrial waste and for other cases. Okay. So also for last 2 days we are also discussing on this. I think Arvind, you might have heard about when we were talking about, I mean, so far only we are talking about how to do this tailing dams. So there also we are all using these mine tailings.
Yeah, one of the possibilities.
Yes, sorry. Please.
Yeah, please go ahead.
Please. No, you please continue.
One of the possibilities could be, I mean, like people are doing, they are filtering out the sand component, the good quality sand, all right, because most of the mines have been riverbeds and sedimentary deposits. So they get the best possible mine, but that's not going to be a solution in my opinion, because when you are going to backfill them from where the material would come. So this is where we are working on these ideas also, bringing ministries together, Agriculture Ministry, Ministry of Urban Development, and particularly Ministry of Mines and Coals in the country, because we are trying to create synthetic backfill materials.
Okay.
And so the person who has asked this question should try to think a bit on this, and this has to be demonstrated.
Okay. So next is Dr. Shankar Singh Kushwaha. So he has asked how this bioremediation is useful for industrial waste management like red mud and marble slurry.
Well, this question, I think Professor Sarath Das is a guru. I am not much into it. And I'm sure he has done a lot of work in bioremediation. I mean, there was a time when I wanted to really neutralize high pH, acidic soils, in fact. And basic soils also by using bacteria. But Sharath has done a lot of work, so please be in touch with him. I haven't worked in this area.
Yeah, I can say that yeah, one of my students working on it. So he could add some bacteria derived from the red mud itself, then cultured it and try to put it. But you have to create an atmosphere. I mean that what I'll say, what I can say the proper suitable media. So where these bacteria can grow. So the problem was that in the red mud some bacteria also, but they are in like a spores. They are in I mean that dormant mode. So if you can feed them something, they will be active and they can do all this neutralization. Okay, next comes eco-friendly measures to adapt to remediate IBPs in geo-environmental aspects. What are the eco-friendly measures to be adapted to remediate IBPs?
I mean, geopolymerization itself is a good example, I would say.
Okay.
Number two is what you are talking about, the bacterial neutralization. And very recently, Government of India has become a part of ACT. I don't know whether you are aware or not.
No, no.
And there was a call of proposal, multinational collaborations were created. And this is accelerating carbon technologies. This is the first time India has become a part of this club. And under that, CCUS is becoming a major hit. That is carbon capture, utilization, and storage. So our group is very active in this, and we are trying to sequester carbon dioxide from the industries, particularly the stacks, which are emitting carbon dioxide and different type of flue gases. We are trying to inject them into the industrial byproducts and create neutralized material, which is man-made synthetic soils. So I think these are the three good examples, I would say, if you can master, that are going to be extremely good, beneficial for the industry and for individuals like us. Please check it on net, CCUS ACT calls. So this year it's over, it was on 15th of March. And but I'm sure next year also this call will come, and many of you can participate in this.
Okay, that's very good, Pratash. I think you should be in touch. Next one is similar way. Here, Srinivas has asked, any funding from international agencies available to take up these projects at research level for students?
Sorry, I did not get it. Say it again, please.
You are talking about this funding, CCUS. Similarly, is there any funding for the students, international agencies, some funding for the students?
DST offers a lot of, facilitates a lot of sponsored research. Please go to the website of DST, and I'm sure there are so many schemes for future faculty members, present faculty members, and students and entrepreneurs.
Okay.
And I'm sure that if you look into it, it's quite viable. The most important thing is that I'm sure you will realize that days are gone when people used to do only research, and now the entire R&D is basically application oriented. So please have this thing very clear cut in your mind, that whatever you are doing, whatever you are asking for money, has to be demonstrated somewhere. And I'm very thankful to the Government of India for imposing it now. DST has imposed it, in fact, for all the projects. You have to have an industrial partner.
Yes.
And they have to contribute in cash, not the kind. I mean, this is how they want to see the motivation of your collaboration with the industry. So the best answer is, please collaborate with your neighborhood, municipal bodies, city administration, different type of funding schemes which you have, and of course international collaboration, which I'm sure you will enjoy to be a part of, because you tend to learn a lot from international collaboration.
Yes. So our next query is red bond, like from Gayatri, is red bond amendable? Okay, is red bond amendable for stabilization with cement?
I'm like, why would you like to go by my answer? Why don't you try it yourself? I mean, I may say something yes or no, but then as a researcher, you should never buy this. So you please try doing yourself, whether you can bind the red mud by using cement or not. Of course, this is our patent, by the way.
Yes. So that's why actually
My answer as a researcher would be, on its own, if you bind red mud with cement, it's not going to work. Now the question which I'm going to ask you is why? So this is where the research starts. And this answer, I don't think anybody should be giving to anybody, because then research stops. So you have to understand a material's, what is its chemical composition, mineralogical composition, what is physical composition, grain size distribution, the type of chemicals you have in them, the type of oxides you have, the type of minerals you have, and then you are adding something to this. All right. So whether the reaction is going to take place or not, number one question. You keep on adding something, it's not going to work. So please try to go systematically as a researcher, take X, Y, Z, and put them together and observe what happens under the climatic conditions, under the different types of curing conditions. And then I'm sure you will be getting the results, answers to your questions. I think that is what should work.
yeah, actually that's what you have said correctly. Instead of getting the ready-made answer, it's better that we have to think about, doing and verifying ourselves. That's very important. As a researcher, we have to verify the things. And Arvind has again asked, what is again the question is, using mine tailing for geopolymer production, as mine tailings are mostly aluminous silicate materials, but reactivity is very low when compared to slag fly ash.
Well, I think you should understand a simple concept here, that activity can always be enhanced by physical processes. Hope you understand. Activity can also be enhanced by chemical processes. All right.
Yes.
And activity can also be enhanced by physico-chemical processes and by adding minerals also, or creating, precipitating, or mineralization of something. These are becoming very, very big terms in today's environmental geotechnology. All right. So my suggestion to all of you is, please try to pick up these words, sit down, spend time. Nobody's going to give you answers in 2 minutes. And understand these adjectives: mineralization, precipitation, all right, chemical weathering, chemically etching a material, silica, dissolution, why silica should ooze out, dissolute in solution, and form a gel with some material. Fine. Or simple, let's say, physical processing I might do, and a very coarse material I might grind to create a hyperfine material.
Okay.
Fly ash is a good example. All right. Fly ash is a good example. So what most of the guys are doing, entrepreneurs, young guys I have seen, they take fly ash from ponds and they just physically treat it and they convert into hyperactive silica. It's a big business. The same thing I have been doing in my laboratory, creating zeolites by adding chemicals at very high pressure and temperature. So I'm like, if you allow me to show this book, this is a book which we have written on fly ash zeolites. So I hope you will realize that a lot of chemical treatment was given to the fly ash. And I'm sure in the audience I have Dr. Kole, who was the pioneer who started these type of studies in my laboratories way back in I think 1999 or something like that. So he is the person who created this subject, and I learned a lot of things from him. So coming back to the point, physical alteration, chemical alteration, mineralogical alteration, and all these things are going to act to, activation of the material. I hope this part is clear now.
Yes, actually, yeah. So that is, I like your way that you are saying that, not giving the answer. Just you are saying that what is the broad scope, and then also that particularly when we are asking, mostly hope our participants are research scholars. So you are inciting their mind. So telling them that these are the ways they should explore it. That's more important, and research, that they have to check yourself and while doing the anything. So they should not think of something which is readily available and we should go for it. That's more important. The approach your approach I like, that is more important. Just you should not, I mean, that research scholar, you should not think that everything is available and you can just pick it up and take it. So obviously you have to get the information from different sources, then do yourself and get the answer. That's why Professor Singh, what we saying, that's important. Try to take it, and that you can take it home. So this is more important. Okay, so then that one guy says Giri Rao as use of bauxite mining waste. So how it, I mean, that's just simply the question is not clear, but I can write down where I can use this bauxite mining waste.
So my suggestion and request to all of you is please stop using the waste anymore. The whole talk was revolving around the fact that nothing is waste in today's world. You know, these are all man-made resources. So the moment you say it's a waste material, the connotation is different. I think please stop doing the word or using the word waste, you know, do away with it. It's all man-made resource, number one. And bauxite residues, I call it as, I mean, they are finding a lot of applications in things. One of my students is also working on COMSOR, that is composites created from socio-economically refused materials. Now, what is socio-economically refused material? If you read the papers, you will realize that, you know, I mean, these are big philosophies, but please go through that paper where we have talked about composites which can be created out of different waste materials. All right, please visit my website and just have a look at that.
Okay, thank you very much. I think we had good discussion. I mean that I'll tell the research scholars, particularly most of our participants are young research scholars and young faculty members. So it was a nice discussion. In fact, I will say, so that word waste we should not use, like what Professor anything said, that we are better to use, and we can go for that www waste to welfare to so wealth and for welfare,
Waste to wealth to welfare,
waste to wealth to welfare. So that's more important. If we can give that tag, so obviously people will also the concept. And the last one I liked, you says socio and economically, what that's exactly is. Can you repeat please? Composite, some composite you have said.
yeah. Oh, COMSOR, COMSOR, COMSOR.
So the last one is
composites made up of socio-economic refuse.
Oh, socio-economic refuse. Okay. So actually that is exactly, if you remember 30 years before, people are also thinking about these fly ash as a refuse. Now slowly it has become a resources. And in fact, one of, I know from Paradip, they have got a plant of that SR. They are selling and ships are coming from Arab and other countries to take their fly ash. So 30 years or then before that, when you were working on the fly ash, it was simply refused. Yeah, so that's thank you very much. So, and I think all of you to just take on this, that research how to do it. And because we are talking about tailings, nowhere we are talking about mining waste or industrial waste. So we are saying mine tailings, coal mine overburden. So as Professor Singh also said now, so we have to say as byproducts, and that what we can use it as for that what the theme is, that for sustainable development. Yeah. So thank you, Professor DNC, and we will continue.
My pleasure. Thank you very much for giving me an opportunity to speak out my heart and mind. And
no, it was really educating to our participants to all the new BSN mode which is coming up in India. So we should all, all of you will be interested to know more about it, and they will contact you through your website.
Thank you.
Thank you very much.